Okay. The last thing that we have here is chapter 3. I think I remember that we have reached until the example, the end 1, example 9, right? And before that, I want to review what we have talked in the previous chapter. As you know, here this is the brief what we had in the previous briefly what we have in the previous lecture is the pure substance mode. As you know, we have here the status of the materials. We say that when we have any fluid like this, and it is in the initial status, let's say it was in a known pressure with a known, because you know in the thermodynamics we have in the thermodynamics we have just let me in the thermodynamics we have only those status of the materials in a given pressure with a given temperature. It will be process situation. This situation is called compressed liquid. Means what? In a compressed liquid, when we have atmospheric pressure or the pressure is 1 atm and the temperature is T, it means that the water is or any water, maybe any water or any liquid, it exists in its normal status or normal phase. This state is called compressed liquid. And when we start heating this normal water, it is going, the temperature will raise from 20 to 100. This process is called state 2, which is called saturation liquid. Saturation, the term saturated, it means that you are about or close to have a status which is not liquid, or it is from liquid to vapor, from vapor to superheated, and so on. So when we start heating the water from 20 to 100, it begins to, due to heat, it's go to the a status called saturated liquid. And the process from 1 to 2, this is the process is called 1 to 2. This is the first process. And if we keep heating this water until a certain time, so then we will notice that the water or some of the water, the mass of the water, will come to become a vapor. This is another status. This status is called saturated, means we have some of the water is saturated and part of it becomes vapor. So it is a mixture between saturated and vapor status. Okay. Next, when we have started again, this is a saturated vapor, this is a saturated. So it is in the tables denoted by F and, sorry, this is F, this is G. So when we have, for example, we have specific, when we have specific volume like this is a specific volume, means how many kilograms that we have in, so how many, when we have how many kilograms, when we said how many kilograms that we have in a meter cube, means this is a specific volume. Specific volume, it means the volume divided by mass. And so due to this situation, we have the mass, the volume, the liquid, the gas, part and the fluid part. That's the mixture. It's a mixture between gas and liquid or fluid. Now, when we have this part, it means some of the mass of the total mass of the liquid becomes a vapor. It means in this situation we have energy like U, that's the kinetic or kinetic energy, U of G and U of F. This is specific, or let's say this is a kinetic energy of the and it is measured by kilojoule per kilogram. So when we have the fluid here, so in the specific temperature, we have UF, it means kinetic energy, how many kilojoules that every kilograms of this fluid held. And for the gas, also we have how many kilojoules of the gas is holding per 1 kilogram of the gas. And we have UFG, which is the mixture of the volume and the gas. And this can be very well cleared in the tables. In the tables, if you remember, let me share the tables again with you. It was here, this was the tables that you earlier, I sent it to you in the classroom. Yeah. Okay. I have sent you this. This is the tables of the thermodynamics. It have many. Here's the most tables that we have. We have here the tables that we have. For example, table 1, table 2, and mostly we are dealing with table starting from table A4, which is for the saturated water, the first process, and the saturated, and we have, for compressed liquid, that is the first process. And we have superheated, and we have saturated water pressure table, and so on. So in each of these tables, specifically A5 and A4 like this, you can see in each of the tables, here in the tables we have what we have, it deals that this table belongs to saturated water. In a specific table, it's called temperature table, means you have the temperature is rising while we have in the second column the pressure is available. Now in each of them, like if we have a water in like 25 degrees Celsius, the saturated pressure is what? Is 3.169 kilopascal. Means above this it becomes it's compressed. Now for each of one we have the internal energy. Internal energy means U. That we have U of F, that means if it is the fluid, and U of G, which is the gas, and U of Fg, which is the mixture of the gas and liquid. Now this internal energy means how many kilojoules will be provided by each kilogram of this material in this status. Now this belongs to saturated water, and we have A5, which belongs to saturated water again, but with a table. It's called pressure table. That means we have the first table column is a pressure, and the second is temperature. The variable is a pressure, is a temperature. This is always a review for previous lectures that we have. Now back to our exam, let's say, our slides. We have done with those examples specifically, and we get till the example 9. Okay. I don't know whether you have any question till now, or keep going. Any questions till now?
No, doctor, thank you.
Okay. Now I'm keeping going, and by solving this example, which is the last example in your slides, we will remember all the previous examples in together. Okay. Now, simply example 9 is here's example 9. Yeah. Here's simply example 9. Example 9, it gives you what this table. This is a table. It said determine the missing properties. Properties means what? Means temperature, pressure, kinetic energy, X. And if you remember, what is the X? What is called the quality. Anybody can answer what is the X? Hello? Can you tell me what is the X? Nobody knows? Nobody remember? X, simply, if we back...
Doctor, it's the mass of gas over the total mass.
Yes, exactly. Exactly. It's a portion. Means what? It is, for example, in this status, we have whole mass of the water, which is about to become vapor, right? Now, a part of this water become vapor. Or let's say this is a gas, vapor or gas. A portion of the mass, which is M gas, become a gas. What left is the M liquid, and the total M gas that plus M liquid or fluid is the M total, the total mass of the whole body here. Now, X tell us that is how much is the mass of the liquid, of the fluid becomes vaporized with according or with respect to the total. That's the percentage. This gives us it's called quality. Quality means how much percentage. For example, if the quality is 100%, means 100% of the fluid becomes what? Becomes a gas. That's the, I think you now remember, right? Now let us back to the question. Now, this example will help us to remember how to use the tables with it. So it tells us to fill these values. So for example, case A, this is item or part A. Part A of this question tell us this is a missing. This is a missing values and this is a missing the value. So tell me what is these values. Now, about this phase, we have a water. This water, this is a water. This water, it has a pressure, which is 200 kilopascal. And a part of this water, 60% is X. What this means that what is the phase description? Tell me which phase is this? Can anybody answer? When we have X equal to 16% or 60%, 60.6, what tell us this? When X equal to 16% or 0.6, means we have this phase. Why? Because 60% of the mass is become of the fluid of the waters become gas, right? So now you can tell me what is the situation. The situation is it is what? It's from 2 to 3. It's a saturated liquid and vapor mixture. So I can directly answer this case by saturated liquid and vapor mixture. Now I can say This is a saturated mixture, vapor mixture, liquid vapor mixture, right? This is what we have here, like in the, saturation. Now we have, this is the first term, is saturation. Now, this is how to get, those are the missing values. So I want to see how to find these values. Back to the question. Now, remember, this is a saturation, okay? The pressure is 200. Now I have to go to table. The tables, basically, because it's a saturation, I have to go to the saturation table. Now, saturation table, if you remember, here's the saturation table. Now, I want to see what is the saturation table. Here's the saturation. Yeah. Now, the saturation, if you go back to the tables of the properties of the liquids, of the fluid, you can see here's the saturation. Yeah. Where is the saturated water? Here's those two tables are related to saturation water. Now, since we have the pressure known, so I have to go to table. Which table? Can you hear me? Anybody answer?
Yes, we can hear you, doctor.
Okay, what is exactly what I have to do? I have to go to
Table A5.
table A5, right?
Yeah.
So I have to go to table A5. Now, table A5, here's table A5. A4, this is A5. Now you can see we have in the right table. Table A5 means you have in a saturated water, and I said because we have a portion of it's a saturation, and because the pressure is known. How much is the pressure? Is 600 kilopascal, right? So I have to go in this table and go down to see, here's the table. Here's the table that I have 600. Now let me go back to note. Now I have to go to table saturated. Yeah, this is the saturated. Now you have the pressure is given how much? 200. Where is the 200? This is the saturated table. This is the pressure. And I have go back to find what is the pressure. Here's the pressure. Am I right? Now, for this one, I have to go these values. Okay. Now, when we have 200, so what is the temperature? Related temperature to this pressure is 120.21, right? 120 and 22.21 degrees Celsius. So what I have to write, I will write 120.21 degrees Celsius. Let me write it in a good way. I said 100, how much? 120. How much was the value? Please remember me.
120.21.
120.21 degree Celsius. So I'm done with this one. Is it clear how to find this? Now, what left? Now I have the temperature, I have the pressure, and here's the table of temperature and pressure. So what is the required? It's required to find the U. What is the U? Is the kinetic energy. So remember that you have 60%. 60%, it means 60% out of 100% is a gas. So our 40% is what? Is liquid, right? So each of them have its specific kinetic energy. So to find the kinetic energy, I have to what? I have to use for each of them. I want to see how much is the one. So I have to use, first of all, the 40%. 40% of the mass is with a fluid, right? Now, what is the energy of the 1 kilogram of this fluid hold in this? Well, here's the temperature. Here's the table. So you can see here's the kinetic energy, right? So for the saturated liquid, which is the F, I have to go down till I will get, here's what we have, right? So I have 504.5 kilojoule per kilogram. That's what is the 40% is holding, right? Plus, so there are some of the liquids has it's a mixture between the gas and the liquid saturated. So those are called UFG, vaporized. Now to do that, also I have to use, for 1 kilogram of the mixture is holding how much? It's 2024.6. We have kilojoule per kilogram. And remember, this is 60%, 0.6%. So 0.6% of this one, it will give you the total energy. So the total energy, it is a mixture between 504 plus 0.6 times this value. Now, if you calculate this, how much is it will be? 504. Can anybody answer? 504.5 plus 0.6 times 24.6. Anybody help? كيف نحسب كم؟
قاعد 1000 حوصوها جدا
1000 also هجده point
76
now that's the kilojoule per kilogram. So simply I have to go here and write what was the value 0.76. Okay, so I'm done with the first part of these questions. And by the way, this was one of my exams, final exams questions. So it simply tells us how to use the tables specifically for this part. It's a kind of review. So this is a saturation. Anybody have a question about this? Let me check the PowerPoint. Yeah, this was. Now, the second part of this one, here's the first part. So this was 520.24. This is we have done with the, yeah. This was the first one. This was for the fluid alone, and this X was 0.6, and this was for 2024. And by the way, this is the U fluid gas value from the table. This is what the final result. Now, to go to the second required part of the question, which is B. Okay, this is the B. Now in B, what we have here, we have the value of the temperature is known, but what is the unknown is the missing. Here's the missing, and here's the missing, and here's the missing. Now the temperature is given, and while we have what? While we have energy, the energy means how much energy can be given by this water, which is, this water is at a temperature of 125. Now, there is a rule, and simply this rule is tell us whenever you have 1 kilogram of water, and this water have been heated, okay, now like this, and this is when we heat something, it means you are increasing the U. U means you are giving heat, and it will give you heat, U, kinetic energy. When we checked the energy inside this or inside this, inside this part, piston, when we have the U value is greater than the U value when we are in this status. So the rule will be like this. Like this. When we have, okay, the case is that if the U or the kinetic energy of that kilogram of the joule of the water that we have is below the where we have energy from fluid, that's called compressed liquid. It means that you have only compressed a water in a temperature, specific temperature, and it will not that much heat, or it has not that much kinetic energy. So it is like just you are heating and compressing the water, compressed liquid. While if you keep going and you have the kinetic energy, it's more than the compressed and it is below the gas, so it's called saturated mixture, that like what we have in the case 1. Now if we have checked the energy, the kinetic energy of that water, and it was greater than the kinetic energy of the gas itself, the water when it is in gas, so it means what? It means that the water is totally vaporized, or it means that totally the liquid is superheated. That's called superheated. Now, what we have here is we have the temperature is right, it's 125. Oh, I'm sorry that I have erased what we have. Okay. Here we have, okay. Here we have what? Here we have, it is the energy is given, U. U, it means 600, means 1,600 kilojoule. Now what left, I have to check which situation is that. So I have to start with, is it for myself, is it the process or is it a mixture saturation? Mixture or not. So to do that, I have to check the value of 116, and I have the what? The temperature is 125. I have to go to the table. It's called table, superheated table. Superheated table, I will assume that we have water superheated, fully gases. So the temperature is 125. Where is the 125? Sorry, I have to go with table 5, A5. Yeah, this is the table A5. The temperature is 125 degrees Celsius, right? Look at this value. Let me make it bigger. This is the table that we have. This is table A5. I will check with the saturated water. Saturated water means if I have a temperature like what we have, what's given to me, this is the table. The table this table at temperature 125, what is the U value? Look at the U value. These are the values of U. The values of U is basically a range between what? Between 444.23 kilojoule per kilogram. That's in case if a portion of it is fluid. And it ranges between, for fully gases, 2530 kilojoule per kilogram.
دكتور مو تيبلا خلاص تشكو تيبلا يبريشر.
Yeah, right. So I have to go to A6. Saturated, oh, sorry, you are right. Okay, so I have to go to A4. Let me check A4. Thank you for letting me know. Yeah. So I have to go to table, temperature table. Here's the temperature A4. Where's the A4? Yeah. Temperature table. Here's the temperature table. So what we have here is the 125. Now, for 125, I have, this is 125, right? The 125, it has, here's the U value. The U value is what? 524.83, right? That is if I have liquid. U of the gas, which is 2,534, right? 0.3. 2,534 kilojoule per kilogram. Now, back to the question. The question says that this is the case. I have the temperature is 125. And the U value is what? U value is 160. So basically, it means that we have, in this case, 1,600 that the U value. So it is light between those two values. So by this way, I have to know that I am in which condition? Saturated water. So simply I will write here, the case is saturated water. Like the same saturated water. Is that clear? So how I did finalize, or how did I discover this in saturated water table or as a condition? Because of the U value. This is the U value. I have 1,600 kilojoule for each kilogram of this mixture. So it is laid in what? In this table, which is at 125, then I have a U value which is 1,600, which is laid between those two ones. So it means that I'm in a correct table. And from that, I can say, what is the pressure? This is the pressure, or saturated pressure. Saturated pressure, it will be 232.23 kilopascal. So simply, I will go here, I would say, how much is that was? 232. 200, I will write here, 232.23 kilopascal. Now what's left? I have done with this missing value. I have done with this missing value. So what's left for me? Now, since the U is 1,600 kilojoule, so basically there will be a portion. This is a quality, because if the total was vaporized, then this value shouldn't be 1,600. It should be how much? It should be 2,534. Now, since we have 1,600, not 2,534, 434.3. So there is some kind of x. So how to find this x? X basically is 1,600 minus, 2,534.3 minus 1,600 divided by 2,534.3. Now, what I left, I will find the delta. Here's the delta. So I will find the UF value. It means if I want to declare that more specifically, this is the U fluid, this is U gas, this is the U that I have, U, which is 1,600. This is 2,534.3, and this is how much is that? 524.83. So simply I have to do what? I have to do interpolation. Interpolation is you have to find this x. X can be done by this value. 2,534.3 minus how much? Minus 524.83. That's divided by who? This is it's 1. I think it's like this. So yeah. The x is like this. X is equal to what? Is this difference divided by this value? This difference is 2,534 minus 34. That's the x. Is this one value? This value is 1,600 minus 524.83. So to do that, what will be the value? Let me do it again for you to be more clear. Okay. X, this is the U value. We have, this is the UF. This is the UG. UF 524.83. This is the U, which which is 2534.3, right? Our U is 1600 kilojoule. Now, this is the definition of X. X is equal to this part divided by this part. This part is what X is equal to this part. This part is 1600 minus 524.85 divided by this part, which is the 2534.3 minus 524.85. Or we can say this is this part, which is the UGFG is the UG minus UF. It is the same. So 1600 divided minus 524.83 divided by Shema Mamboka calculation. Ever can you calculate?
جان دكتور استيقظ
دكتورة قاعدة point بنجوسي.
Very good point. Panjose. George Kamian with
شاغل.
point Panjose. So what we have X here, our right.
بله
Panjose. So I have done also with this part. Now I have the first part, the second part also saturated, and this is a كسر نزاني why I have this value. Let's check the PowerPoints. Okay. Playing Panjos. Here's the point Panjos. By the way, this is the UFG. By the way, it's what? It's UF minus UG. In the table, it was given to you both, all of them. UF is given separately, UF, UG, UF is given separately, and you have FG separately. Those three values given to you in the table. But even it is not given this value, you can find it by this way. UG. I'm sorry. Okay. You can try and use the calculator to find those values. Okay. Now, like this. What is this value? What is the value of 2009 can be checked. How to find this one? That's UFG. It's basically it's the result of subtracting to 524.83 from 2534. You can check. Okay. Now, do you have any question till now? Any question? Persiar.
No, doctor.
Now, what we have here, the part three of this question. It's exactly what we have here in part what? In part B, but with a known temperature, pressure, and a known value of what? Of U. Now I can go to the table of the pressure to see while we have saturated water or not, or it is a mixture or superheated. So to see that, I have to go to the pressure table first. What's the first table? pressure table. Here's the pressure table. And in the pressure table, I have the pressure is 1000 kilopascal, which is 1 megapascal. I can go to the 1000 kilopascal. You can see this is the 1000 kilopascal. 1000 kilopascal, basically, it tells us that if the water in the saturated water condition at the pressure, which is 1000 kilopascal, it is the temperature, saturated temperature will be 179. But I don't need this. I want to see what is the value of the U. The value of the U, it means the kinetic energy can be given by 1 kilogram of this saturated vapor is 2,582.8 kilojoule, right? That's basically. Now, back to our question, part C. Here's part C. Part C tells that it is not 2,000, it's 2,950. We said in our case, it's 2,500. Now, in the question is given to you that each kilogram of this material will give you 2,900, means more than the vapor itself. So I have vapor, which is the 2,582. And I have the case of mine, 2,900 kilojoule. Now, what does that mean? That means we keep heating the vapor to become what? To become something called super vapor or superheated. Now, is that different? Yes. The different thing that I have to not use this table for this case, for part C, because the U is more than this. I have to go to the other table. This other table is called superheated table. I can find the superheated table. Here's the superheated table, or can be A6. Here's the superheated table. Now, if you want to check, where's the A superheated table? Yes. Now look at the tables that we have. Saturated. We have table A6. This is the superheated water. In superheated water, we don't have table for temperature. We don't have alone and table of the pressure alone. We have one superheated water temperature table. Now, I want to go to table A6 to check. That's because, as I mentioned, that we have U is 2,900 more than the available one. Okay, now I have to go to table A6. Here's table A6. In table A6, and as it is given to me, look at the question carefully. What is the pressure?
1,000.
1,000. What's the U? Is 2,950. So I have to go to check with the pressure first. 1,000 kilopascal means how many 1,000 kilopascal means how many megapascal? Means 1 megapascal, right? Am I right? Now for 1 megapascal and table A6, here's the table A6, here's the table A6, and 1 megapascal. Look at the past pressures. Those are the value of the pressures. So I have to go with the pressure. Where's the pressure? Yes. 0.4. 1,000 means, yes. That A6 is not available. Yeah. Now I have go to back to the pressure table. Where's the A6? Because the pressure table A6 2-page, not 1 page alone. So yeah, that's the pressure table, superheated table. I have to check with what? Yeah, this is the page 2. I have to, here's the page. I'll bring this one. Now, where's the one pressure? Here's the value of the pressure, which is 1 megapascal. 1 megapascal means 1000 kilopascal. Am I right? Now, in 1000 mega, and what is the value of U? U, it was 2900 kilojoule per kilogram, right? Double check.
2950.
50. Thank you for the correction. 2950. Now for 2950, I have to go with the value of U. Where's the U? Those are the values of U. Those are the values of U. Can you see that? The U value is like this. Now our value, it's like 2900. That's 50, right? And here's the 2957. So it is between those two values, right? The 2950 can lie between 2875.7 and 2957.9, right? So what does that means to you? Means there is a temperature, it is laid between those two values. Means the temperature will be between those two values while we have for those two values. So I have to make a what? Correlation, or let's say interpolation. Interpolation between temperature, the temperature and the U. Now I have, this is U. The first U, while we have temperature, let's say this is a temperature, this is a U. When we have temperature 350, what will be the value of U? What will be the value of U? Anybody?
2875.7.
2875.7.
7.
Right. And I have a temperature equal to 400. What will be the value of U?
2957.9.
0.9. Now, look at it. So I will do like this. This is interpolation. Okay. Now, where is the our value? The value of what I have is this 2000 2,950, right? This is the given U to me from the table. So this can be laid between those two values. Okay. Now that's the value of t. So t is equal to what? Divided by this. It's equal t is equal to 350 plus from here to here. Let's say this is x or any value. So when we have this, it's basically to interpolate. Interpolation can be like done like this. 2,957.9 minus 2,000. Let me do it here. I can say I will say temperature is equal to 350. This is the first part. Plus this portion, to find this portion is basically what? It's this one divided by this one, like this one divided by this one. So it is 2,957.9 minus 2,875.7 divided by 400 minus 350. Okay, multiply by 2,950 minus 2,875.7. So can everybody do this one? So basically I will do like this part divided by this part, like this part divided by this part. So I wanted this one, this by this.
Siyasal şans 5.4 دكتور.
غلطة.
سياسal كرة ونيا دوای هناك.
بلى multiply. أما ديفايتي أما أوكو أما وايا ديفايتي أما. والله نبر. يوسي غوشيا like this.
دكتور 472.4 دقيقة.
درسته؟ خوش غلط. نبيله 400 زیاتر بێ. خۆ گەلە 400 زیاتر بێ یوەکەمان هەیە 300 شتێک 350 چکە 350 من لێرە بێرە بەس ئێمە بە ئەم چێکم. ئێستا بە ڕێگای شتێکم. ئێمە ئەم ڤالیۆمانێ. To find this ئەمە کاتە چی؟ کاتە 2,957.9 minus 2,875.7 ئەمە ئەم ڤالیۆ ئەمە چەندە کات؟ چەندی کردەوە هێبەر؟ شکار
82.2.
ئەمە 82.2.
بەڵێ.
ئەمەش 400 minus 350 50.
ئەویش 50کە.
ئەمان من 2000 چنه 950 ماینسی 2875 كم
74.3
74.3 so bubbling like this أما divide أو bubbling ما قلنا يبنين y y divide 74.3 is like what 50 divide چند 82.2 y قاعدة چند y equal to 50 74.3 divided 82.2
45.19 أكا
right
بله.
now عمل ريت 45 19 داير الشنكة 350 هذا تي قاعدة 350 plus 45.19 and it's equal to 399
99.19
so it should be less than 400 so I will go to this table to the equation yeah I will say the temperature is it should be 399 point what
19
19 I am done with this now what is the x can you tell me what is the value of x x it means that what is the your case is Whitman x when we have a liquid fluid and gas right so there is a portion of this one mixture now if totally we have all of them gas so what will be the value the x is 100% is vapor so I'm a superheated so means that we have one it means totally we have all of the fluid becomes a gas or vapor so that means the x is equal to 1 without any calculation that's the meaning of this one here's the
دكتور زدني أو دوباره گیتەوە
static look at this when we have the case is like this I became with my element K this the X will be here. It's a portion of vapor
and
to
liquid
what? Total one, yeah.
total yeah
So if we have all of them vapor and all of them total is also vapor. So the percentage X is equal to 1. 100%. It means 100% of the case is vaporized, superheated.
okay thank you okay
Now back to the question. Now here's the question. So that's why we have, and you have to double check with this value, but that's the superheated. It means the X is equal to what? Equal to 1. ساعة
دوانزە شل دقیقه دکتۆر
أنا چند اسمع بكرة ده دخل
یانزە و نیو
okay ده دخل ما اشتغل okay then now sorry it's me again now back to the question the question here is so I am done with this one now you need to remember you double check with this value okay because I don't know why we have in the okay so that was superheated so this was 1 that's 1.53 this is superheated condition that's what 390 something 119 okay now party is exactly what we have here. We have temperature, we have pressure. Now, I don't know what is which kind of condition that we have. Is it superheated? It's compressed liquid, or that. So what we have to do is to check with these two values. So I have to go to the temperature and the pressure table, which is let's say compressed liquid. To do that, I will go to the first table A4. Here's the, I think here. Yeah. To the superheated, no, saturated table. That saturated table, here is the saturated table. In saturated table, I want to check, is this is the value of this. So I have to first of all check, this is the condition. The condition is it tell us Part D tell me to check whether it is. I have to check with the pressure and the temperature to see the case. So I will start with the first table, which is the saturated water. And saturated water, I will start with the temperature. Temperature is 75. Where's the 75? Here's the 75. At 75 degrees Celsius, so what will the saturated pressure? The saturated pressure is 38.59, and my pressure is 500 kilopascal. Means what? Means we have a compressed liquid. We have the compressed liquid because the pressure is greater than P saturated. Now, if you want to double check on this one, you can go back to the slides. Here's the slides. For the part D, look at this one. We have to double check with the temperature and pressure. The temperature and the pressure is given, but again, we have to what? Again, we do have to check whether we have the saturated mixture or the compressed liquid. We have to double check of this one, or superheated. So to have either this one or this one or this one. Now to determine whether the region we are in, we go to the saturated table, which one is the table A5, and determine the saturated temperature as a given pressure. So look at this table A5. Table A5, it tells you the temperature that we have. Now temperature we have 75, and the temperature of the saturation, that means the starting of the liquid to be vaporized. Now temperature, if I have that my temperature is less than the temperature that at that temperature it will be vaporized, then it is not vaporized and it starts compressed liquid. Means you have to go to tables called compressed liquid table. If they are the Ekman, so we have a mixture. If the temperature is greater than the temperature we have superheated. Now this is the condition. For myself, I have to first of all check. So I have 75, and I want to see the T saturated as a given pressure. So what should I do? I have to go to the table that's related to Desaturated, add. So I have to go to the table that is related to, sorry, not A4, A5. Here's the A5. At A5, we have to check. Here's the temperature. I have to go to the, sorry, the pressure. The pressure is 500, right? So at 500, here's the 500. It's the 500. 500, this is 100, 150, 200, 250, 75. Oh, still we have, don't. Okay. Let me check with the table itself. Yeah. Here's the A5. Yeah. Maybe this is the 500. At 500, the temperature. Okay. This is at 500 kilopascal, the pressure. Look at the related temperature. This is called T-saturated. T-saturated means the temperature at which will be start to be vaporized. So T-saturated is 151.83 degrees Celsius. Now remember, we have given that the temperature is 75. Means there is no way to have this case. The case is that we have a saturated water. So if I don't have saturated water, so it's not superheated, it's basically compressed. Compressed case, status. State. Compressed water state means you have to go to the table of the compressed liquid. Compressed liquid, here's the compressed liquid. Sorry, it's not the compressed, the superheated, saturated, compressed. You have to go to compressed liquid. Here's the compressed liquid, compressed. So I have to go to, okay, not saturated, I think A7, right? Superheated, it's not superheated, superheated. You have to go to this table, A7. That's for compressed. Compressed water liquid means that you have to do this one. Now, in the compressed, we have to use the table is, here's the compressed. Okay. I have to go to the compressed liquid. Remember, in the we have temperature is how much? 75. The pressure is 500 kilopascal. Means 500 kilopascal. Now for 75, right? This one we can use. Yeah. We have to use this one, which is the value of those two values. So we have to find the U. Now we have 60, we have 80. So what will be the value of U? We have temperature 60, 80. Now our temperature is 75. Now in 60, we have the U value is 250.29. We have at 80, we have 330. 33.3. So what should we do? We have to interpolate and find the U value here. That will be the first answer of the part, and it's also interpolation. And I will go to this one and I will find the U value. And for the case, it is the, let's say, compressed liquid. Now, what is the portion of gas? Because there is no way to have a vapor, because the temperature is 75, and based on our calculations, when based on our given, to have a vapor, you have to go to what? To the temperature should be more than 151. Now, since we don't have 151, as I found earlier, so it means that all of the gas, all of the liquid still, it's a liquid, it's not vaporized, so we don't have this one, and there will be 0. The X is equal to 0. There is no gases. Now, to find this one, as I said, you have to find interpolation. The interpolation will be like this. How much is the interpolation? 300. Let's say this is the U. 333.82 minus 280.
Doctor,
Voilà.
I think we should use the compressed table with a P equal to 0.5 because we have the pressure here is 500 pascals. So in megapascal, it will be 0.5.
This is, you are right, but there is, we have done, in case that we have compressed liquid, so the matter of the pressure, since we don't have the, we have solved an example on this. There will be a very little of accuracy, so we can use this one also. As you remember, here's the example that we have. Yeah, this was the example that I am done with this. Yeah, remember, we have done with an example that if in case that the compressed liquid, we don't have it, we can use this one, another one way. And I found the error is about 1%, which is very little. We can use it. So yeah, here's I think here's the here's, in case that we have like this one, example 7. Remember this. I don't know when that was in the earlier. Yeah, in example 7, remember that we have used compressed this table A7, which is about the compressed liquid table, with the table A4. We can use both of them, two ways to find the saturated table or compressed. Now, we can use this one or this one, and the error, it will be very little. It's less than 1%. We can use them overall. So that is the for compressed liquid. Now like this one, it's 5 megapascal, while we have using another one here. It's never mind to have to use the table A4 also. Back to this one. So we can in case that we have, because like this, where's the pressure? The pressure is 5 megapascal. And in our case, what's the pressure? It's 500 kilopascal, which is 0.5 megapascal. Do we have in the table 0.5 megapascal? No. In table A7, it's not starting with 2. It's directly with 5 megapascal. So we cannot use this one directly, but it can be. It will give you somewhat some approximation, some error. If the error is less than 1, we can do like this to find the U, and it is between 250 like 330. It's about 300 something. Or you can use table A4. Where's the table A4? Here's table A4. Yeah. In table A4, you can see at like this 313. 313 is the value of U, because table A4 will give you what? Temperature and P saturated. 500, we don't have 500, right? We don't have 500, but we have only 75 temperature. So we will go with this one. And we say that U is 330. Directly. 313.99. While if I am using the other table, it will be, as I mentioned, it will be between 250 and 333. In the other table, I said it is 313. It will be the same approximation, right? Okay.
دكتور
والله
ساعاتيك وزياينك
مزاجي.
والله
Okay. بس أنا تشيكي ممكن ما تشندرشون about we'll give you about 313 now and أمش صفر. Now the last part I will leave it for you. أما يكب for as a homework.